So, hello everyone. I will be doing exercises from chapter 2 today, and from the next week, we will start chapter 3. Chapter 3 is about statistics, so we will review some concepts that will be very useful in practice. I have heard from some of you guys that the recording that I have on the link of the recording that I have on the CUNY Blackboard, you said that it is cut. So, but it's not true because, I mean, maybe it is, but when I checked, the recording is full. So the length of the recording should be about 1 hour and 15 minutes. And if it is about 1 hour 15 minutes, then it's yeah.
You have to download the video for it to be like full. You can't just view it on the website or through the link itself. That's what I found out.
Oh, really? So that's really, because when I clicked on that link, on the links of the recordings that I have on the CUNY Blackboard, it does show 1 hour 15 minutes, and that did allow me to watch the last part of the recording. But anyways, guys, there's nothing I can do because I try. I do see it that it's full. It's not cut in the middle or in the last part. So, but as you said, I mean, if you can download the recording, then please do and watch the recording if you want. So let me now open Pearson's My Econ Lab because I want to share the textbook, and then I will start solving problems. As you guys already know, I assigned the homeworks. I am very happy that you already started doing homeworks. That's very good, very important. If you have any questions, I will have office hours, and of course, you'll be able to ask questions. So now you just see my blue Word document, right? You don't see the textbook. Guys.
Yep.
Okay, so you should be seeing the textbook. So let me now share a different screen. I will do certain exercises from this chapter, and in addition, you'll do the homework. These exercises are part of the homework, but I do want to do some of the exercises to help you guys complete your homework, and this will be also very, very important for the exams as well. So let me stop sharing. Maybe I can share a different screen. Okay, do you now see the textbook?
Yes. Yes.
Good. So we will start doing exercise 2.2, and then we will do exercise 2.3. What I will do is that I will copy this in the blue document or document that I have. So we need this. You will see everything, guys, so don't worry, just give me a few seconds. Okay. And we need this table. Copy. And then paste here. Okay. And we are done. Now I will share back this blue screen. Okay. Okay, guys, do you now see my blue Word document? Also, these the exercises. These are from the textbook.
Yes.
Yes.
Very nice. Good. So let us do these exercises. So we have this joint probability distribution table. We have two random variables, X and Y. Both of these random variables are Bernoulli type random variables. As you guys know, Bernoulli random variable takes only two values: outcomes, possible outcomes, success and failure. And you know, success and failure can be defined in many, many different ways. In this case, success is that it doesn't rain for X, and for random variable Y, it's defined as a short commute. Failure is rain for X and long commute for Y. So we are in exercise 2.2. We are asked to calculate certain measures of from this for this random variable X and random variable Y. We will start by expectation of X, right? Y and expectation of X, and then the variances of those. So part A, expectation of Y. This is yi times probability that the random variable Y takes the possible outcome phi I, but you have to sum this product over all possible outcomes. And how many possible outcomes do you have for Y? Clearly 2. So then we will have the first possible outcome. So this will be Y1 times probability that Y equals Y1 plus Y2. The second possible outcome of Y times the probability that your random variable Y takes this value Y2. So and we have, what's the first possible outcome of phi? That is 0, right? What's the probability that Y equals 0? That's
0.22.
0.22 plus the second possible outcome of phi is 1 times the probability that the random variable Y equals 1, which is in this case 0.78. And then clearly you will have 0.78 here, right? Because this is 0 times 0.22. But you know, you can have, like in this case, Y takes values 0 if long commute and 1 if short commute. But these like 0 and 1 choices are really arbitrary. You could say, instead of 0, let's say 1 and 2. 5 and 67, whatever, right? But then if you do that, this should have some sense, right? So like, it makes more sense if you just define success by y equals 1 and failure by y equals 0, right? But it could be any other two numbers. And then clearly you would not have 0 here, and then you would not have this answer. So be careful, think about the problems that you have, and then solve them. So let me just ask you guys, what are these probabilities called? Can you remind me?
Is it marginal?
Distribution.
Those are marginal probabilities, right? Because this tells me, this one, what's the probability that y equals y1, which is I am taking short commute, no matter it rains or not. So I don't care about whether it rains or not. I'm simply interested what's the probability of a short commute. And that is on the side. So I already said before that the probabilities that you have on the sides, except this one, those are marginal probabilities, right? And inside you have joint probabilities. And then based on these numbers, you can calculate conditional probabilities.
That's
Similar, yeah.
Sorry, can you go over how y1 is equal to 0 again?
Yeah, because
Like
you have
yes.
from this table. From this table.
It says y equals 1 is 0.78. Is that the same thing or is it different?
So this tells you that this like 0.78 is the probability that the random variable y equals 1. So it's like probability that y equals 1 is 0.78, right? From this table. And did I answer your question?
Yeah.
And similarly, you will calculate what's the expectation of x. That will be 0 times probability that x equals 0 plus 1 times probability that x equals 1. What's the probability that x equals 1? 0.70. So therefore, we have 0.70 here. The next question is,
Professor?
yeah.
I have one question about the chart. So for example, if we do test questions, do they usually give these charts to us?
Yeah, if you don't have this chart, then you cannot really calculate anything, right? So you do have to have this kind of chart, or at least you have to know these probabilities to calculate these expectations, right?
So they will already give you those numbers, like
yeah, definitely. Yes. Those numbers are like those numbers are perceptions or whatever, so they are taken from somewhere. They're not estimated, nothing. So these are like this is just an exercise, and you know we will be estimating certain stuff in the future, but this is like assume this chart and the numbers you see here are given.
So 0.15 represents the possibility that there is rain and there's long commute, and then 0.07 is the possibility of having rain and long commute. And then the total would be, the 0.22 would be having long commute with rain or no rain, so just having long commute.
Let me clarify. So 0.15 is the probability that it doesn't rain because x equals 0. Sorry, it rains x equals 0, and there's long commute as you said before, right? And exactly similarly, 0.07 represents the probability that there's no rain and long commute, and 0.22, this tells us what's the probability that I have to make a long commute.
Oh, okay. Yeah, I see.
Nothing like, I'm saying nothing about whether it rains or not. I don't really care about that in this case. When I say what's this 0.22, that's the probability that I have to make a long commute.
Okay, thank you.
Now let's calculate variance of X, which is usually denoted by sigma squared of X. This is like a subscript. And this is, as you know, the sum of yi minus expectation of y. And note that I write small y here, uppercase y there. So please notice all of this, like whatever I write. I'm trying to be like, it definitely can make some typos, that because we are humans, but definitely notice that how the way I am writing stuff, like, okay.
Wait, sorry. So which one's the small y? The one with the I next to it?
Yeah, so this is like, I write small things like this, and this big Y will be like this.
Oh,
small,
okay.
small x will be like this, and big X will be like this. Small z will be like this, and big Z will be like this. So
yeah.
And the difference is that, so okay, these are random variables, and these are outcomes.
Sorry, what's the symbol in front of their variable of X?
This?
What's this called? Yeah.
The variable X, very sad. Oh my God. Okay, I should have said Y here.
Yeah, but what's the
this one?
Little symbol in front of it? That's just
this one?
The one in front of var X, in front of it, there's a circle and a little thing next to it.
She's talking about sigma.
Oh, this is sigma. This is sigma. This is a symbol. Sigma of y. Sigma squared of y. That's the symbol of y. This is the symbol of variance of y. So this will be y1 minus
in the
expectation of y.
Little circle over there.
Where's the circle, guys? 1, 2. So let me. So this is variance of y equals sigma squared of y equals summation. I changes from 1 to 2 yi minus expectation of y squared times probability that y equals yi. Probability that y equals y1, and then plus y2 minus expectation of y squared times probability that y equals y2. So then, guys, if you can help me, will be great. So the first possible outcome of y here is y equals 0. So 0 is the first possible outcome. Okay, then we already calculated the expectation of y, which is 0. Do you see 0.78? Yes.
We have on Tuesday.
What?
We had class on Tuesday. Because Monday was a holiday.
We did not have class on Monday, no.
Tuesday either, right? This Tuesday, following Tuesday.
We did not have a class. We didn't have class on Tuesday. Should we have a class on Tuesday?
No, I thought you probably moved Monday to Tuesday. That's why.
No, because no. I mean, it was just a holiday.
Okay, so I haven't missed anything. Okay, thank you.
No. Just please follow, and this will be like uploaded on the Kimi Blackboard. So let's keep going so that we solve as many problems as we can. But of course, please ask questions if you have. The probability that y equals 0 here will be 0.22 plus then the second possible outcome of y is 1 minus 0.78 because that's the expectation squared times the probability that y equals y2. Y2 is 1 in this example, so then you have 0.78 here. And if you do this multiplication, sorry, if you calculate this thing here, you would probably obtain, okay, whatever, but 17, we can double check that if there's a mistake, then correct. But I think that's
Yeah, that's what I got.
Then similarly, you will calculate variance of X, which will be 0 minus the expectation of X, which is 0.70 from above. Square it and then multiply by the probability that X equals 0. That's 0.30. Then plus 1 minus 0.70 squared times 0.70. And this will be 0.21. And then you may be asked, so this is also denoted by this three sign, this means denotes. So this is denoted also by sigma squared of X. This is a symbol, right? Now you can calculate sigma of X. This is the standard deviation. This is big X, which is clearly square root of sigma square root of X, and that's square root from whatever we have above, 0.21, right? And you can also calculate sigma of Y, which is square root of sigma square root of Y, and that's clearly square root of 0.760. Okay, now the next question is to calculate what's next? Sigma xy stands for covariance between X and Y. The next question is to calculate covariance between X and Y, which is also denoted by sigma of X, Y, X and Y. And this is, as I think I already told you guys how to calculate this, is your probability that X equals 0 and Y equals 0. Then you have another term, probability that X equals 0 and Y equals 1. And then you have probability that X equals 1 and Y equals 0. And then you have the last one is probability X equals 1 and Y equals 1. Okay. So then what do I have here? The possible outcome of X, right? 0 minus expectation of X. Here Y also is 0, so 0 minus expectation of Y. Then what do I have here? 0 minus expectation of X. What do I have here? Y equals 1, 1 minus expectation of Y. And then clearly here will be 1 minus expectation of X, 1 minus expectation of Y. Here will be 0 minus expectation of Y because of this. And then 1 minus expectation of X. And 1 minus expectation of Y. And these expectations we already calculated, right? So this will be then, let me change the color. Then this will be 0 minus expectation of X is 0.70. 0.70 times 0 minus expectation of Y is 0.78. And then what's the probability that X equals 0 and Y equals 0? That you will be taking from the table, which is 0.15, right? This is 0.15, right? So analogously, you will do these things as well. 0 minus 0.70, 1 minus 0.78 times x probability x0 y1, that's 0.15 again. And then you have 1 minus 0.70 times 0 minus 0.78, and then probability of x1 y0, that's x1 is 0, y0 0.07, right? And then the last one is 1 minus 0.70 times 1 minus 0.78, and times probability x equals 1, y equals 1, which is 0.63, right? And then if you do this, okay, and clearly I forgot, but the thing is, you have to add all these expressions, sum those up, and then you will get 0.084. That's what I have here. And then if you want to calculate the correlation coefficient between x and y, then what you do is just do this. This is also denoted by a rho of xy. This is defined as covariance between x and y divided by sigma of x times sigma of y. So this will be 0.084 square root of, because I have not calculated sigma of x, but I have this, right? So that's square root of 0.21 times square root of 0.1716. Okay, guys.
Professor,
Yeah,
will you provide a formula sheet?
guys. The exam is an open book. Everything is like you can, because we are online, right? So everything is the exam is open book. I will give you certain formulas, but you don't really need to memorize anything still, because I mean, as I said, the exam is open.
I mean, just for like studying, just like I could see everything, you know, all the
Yeah,
formulas.
definitely, I will do that. I will give you guys the formula sheet. But so how do you prepare for my exams? That's as follows. So you understand everything I am doing in class. You understand my notes very carefully, and also you understand the class slides very carefully, because in addition to my exercises and examples I give you guys in class, in these blue Word documents, in addition to that, there is some additional examples in the class slides, which are very similar to what I do in class. So, I mean, you need to understand those as well, and do the homeworks. And you should, and I mean, I have experience of from the past experience, students are doing really well. So that's probably because they are preparing for the exams based on like instructions I'm giving. And yeah, please go ahead.
So for the exam, is it going to be administered as a PDF where we have to show work and everything?
No. You will just do the exam will be exactly like the homeworks, except you will have to do it in a limited amount of time.
Oh, okay. So it's on the Pearson.
It's on the Pearson, yeah. Guys, let me do number 2.3.
Okay, sorry about that.
Guys, let her finish. She could explain this much later down the line.
That's a good question.
Yeah, please ask, guys. You can feel free to ask questions. That's okay, but also bear in mind that I will be uploading this on the CUNY Blackboard. So.
So right here, the covariance. What's that little line? It's. Could you hold on, please?
Let me see. This one?
Yeah. So right after the equal sign, there's that little squiggly line.
This one?
No, it's before that. It's so it's COV.
A row.
It's okay.
Okay, that's this one.
Yeah, yeah.
This is
Yeah.
a symbol.
So symbol for what?
For covariance between X and correlation coefficient between X and Y. So correlation between X and Y is denoted also, that is another name of this, like this. Variance between X, for example, is denoted also by sigma squared of X.
Got it. Thank you.
Something like that.
Professor, I just had a quick question.
Yeah,
So
please.
when we're using Bernoulli, you showed us last time that variance could be like basically 1 minus the expected value times the expected value.
Yeah.
Well, whichever variable we are using. Is there anything for covariance that we could use since it's like really long formula?
Okay, so there are some shortcuts. So that is like an extra topic that you guys will clearly see in the textbook. But for this particular exercise, that's the way I think is most effective to do.
Got it. All right. Thank you.
Okay, now let's do this 2.3 because that's also very important. So here we have, so before we had random variable X and random variable Y, and we calculated the expectation, variance, right? We calculated sigma, which is standard deviation, covariance, then correlation. So those right? But for X and Y, but let's now see that we have other random variables W and B, and as you see, those are functions of these random variable X and random variable Y. So specifically, we have this 7 times 1. Okay, now let me give you some. That is also on in the textbook, but also in the class slides. So if you have, so let me now give you some expressions. Let's say Y is related to X as follows. Random variable Y, let's say, is related to random variable X. Sorry, like this. Where A and B are some constants. Constant numbers. Then expectation of Y equals expectation of A plus BX. And this is expectation of A plus expectation of B times X. Because A is constant, its expectation is A itself, and then plus this is B times expectation of X, right? So that's what I have there. And then finally, variance of Y is variance of A plus B times X. And this is if you want to go like, I'm just deriving this stuff like to give you in-depth understanding. So this is variance of A plus variance of A and B times X plus, variance of, I should have here, variance of B times X, and then plus covariance between A and B times X. Variance of constant is what? Can you tell me?
It's A?
0.
It is 0. I said, what is variance of a constant? Does constant have any variation?
It's always the same.
Well, not the same. It is 0. So variance of a constant. I am saying the constant is not varying at all. It is constant, so the variance will be 0. Do you see what I mean?
Yes, I was just saying that the value of the constant is always going to be the same.
Always
So
the
it's
same.
gonna
Yeah,
stay zero. Like the variance will be zero.
that's exactly right.
Formulate that well.
Yeah, that's exactly right. So, and then if you have this will be b squared variance of x. Can you tell me what is this? Covariance between a and b times x. A and b are constant numbers. X is a random variable. This equals 0, right? So we have b squared times variance of x. So we can apply this to this. So guys, we already have everything calculated for x and y, right? Now then, if I wanted to calculate, expectation of w, this will be expectation of this thing, which will be 3 plus 6 times expectation of x. But I know already what is expectation of x, because I calculated that before. This is 3 plus 6 times 0.70, right? Similarly, it will calculate and you get some number here. Similarly, expectation of v, that's the expectation of the whole thing, and that's 20 minus 7 times expectation of y. And that's, I mean, that's clearly whatever we had before will be useful here. Expectation of y was before, from before 0.7, and then you get some number here. What is variance of w? That's the variance of the whole thing, and then I should do some derivation. So following that derivation, variance of w will be 6 squared times the variance of x. But we already know what's the variance of x, so that from before, because we already calculated that before, so that's some number here. And then variance of v, that's, guys, we have class until 15, right? Similarly, this will be minus 7 to this second power, minus 7 squared times variance of 5. And because variance of 5 before was, from before was 0.1716, this will be 49 times 0.1716, whatever number. You can have the answer there. Guys, let me say something because I have like almost everyone here. Guys, definitely please register for the Pearson's My Econ Lab, those who are not yet registered, because as you will see, I mean, there will be a lot of homeworks, and those homeworks are very, very important. Not only because they have a large part in the overall course grade, they also are very, very helpful for preparing for the exams. So please, if you can, register for Pearson My Econ Lab as soon as you can. Now, and then the last one, okay, clearly you can calculate the standard deviations, right? Because there will be square root of 36 times 0.21 there, and then sigma of v will be square root of 49 times 0.1716. And then the last question here is, what's the covariance between W and V, and that's, let me give you this. This is covariance between W is 3 plus 6 times X, 3 plus 6 times X, comma, and V is 20 minus 7 times Y. 20 minus 7 times Y. And then, okay, let me expand this expression. This is covariance between 3 and 20 plus covariance between 3 and minus 7 times Y plus covariance between 6 times x and 20, and plus covariance between 6 times x and minus 7 times y. This is 0. This is also 0 because here we have these constant terms. Also, this is constant. Same thing, this is constant, so this is also 0, and then this is the last part that matters here. So this will be 6 times minus 7 times covariance between x and y, but this is already known from before. We know that from before, 6 times 7 is 42 minus 42 times covariance between x and y. That we calculated was 0.084. And think at a number here. And then the final question that you have here is what is rho, the correlation coefficient between w and v, and that's sigma of w and v divided by sigma of w times sigma, these are big letters, sigma of v, and okay, so then this will be minus 42 times 0.084 divided by sigma of w, whatever you get here, 36 times 0.21 square root from there, times 49 times 0.1760. Hey guys, I mean, I think our class is until 3:45, so we have a lot of time. That's perfect. So okay. So guys, are you following? So are you with me?
Would you mind going over the covariance just once again, just like the process of how we got there? It got a little confusing.
This one?
Yes.
Yeah, so I expanded this expression. So let me give you let me give you this. If you have like let's say you have this covariance a plus bx and let's say c plus dy, b times y, b times x, right? Where here a, b, c, and d, those are some constant numbers. That are given to us. And x and y are random variables. Okay, if x and y are random variables, then you can call this whatever, you can call this w, will be random variable clearly because x is random, and you can call this v. I think I should be clear. And then, of course, you can expand this expression as follows. This is the formula. Covariance between A and C plus covariance between A and D times Y plus covariance between B times X and C, and then plus covariance between B times X and D times Y. Okay, then this is 0. Why? Because by definition, covariance between A and C is 0. There's no correlation between two constants. Then covariance between a constant and a random variable, this is a random variable because y is random, this is again 0. This is also 0. And the only term that we have left is this. So that will be then covariance b times x and t times y, and this is b times t times covariance between X and Y. So I used this to solve the previous exercise. Okay, now let me solve 2.6. From there.
Can you please go up a little bit? Just 1 second. Yeah, thank you. Thank you.
Let me now again share the, maybe not, because I can just copy this from here and paste it there. Okay. Copy. You guys, yeah, you see my blue screen, right?
Yeah.
Mm-hmm.
Professor, so is the homework question similar to these examples you're going over?
Yeah, very similar.
All right, thank you.
Professor, so the exam is going to be the same way as the homework?
Will be very similar.
Thank you.
Okay, now let's solve this. So we have a probability distribution for random variable X and random variable Y. Both are Bernoulli type, since they have only two possible outcomes. Let's calculate the expectation of Y. This will be 0, which is the first possible outcome of Y, times probabilities that Y equals 0, which is 0.035, plus, I cannot really draw anything on this white. Okay, that's okay. 1 plus, and then, sorry, plus 1 times. This is the second possible outcome of Y, by the probabilities that Y equals 1. Really, this is the unemployment rate is the fraction of the labor force that is unemployed. So this is a fraction of the number of people who are unemployed over the labor force, size of the labor force. Okay, and we need to show that it's equal to 1 minute's expectation of Y. Okay. Okay, can you tell me what is this? It's the probability Z.
Probability of people unemployed?
Probably, that's right, but how would you write it using our notations? The probability is that Y equals 0. Am I right? Why? Because 0 means that you were unemployed. So what is this, 0.035? That's the probability that y equals 0. So that's the probability that you are unemployed, guys. So since there is only two possible outcomes, there are only two possible outcomes or for y, which is like you are either employed.
Professor, on the table, is it y minus 0 or y equals 0?
It is equal to 0 and equal to 1. That's okay. Like, yeah, which is y equals 0. Sorry, you are okay. So either you are either unemployed, which will be like y equals 0, or employed, which is like y equals 1. Okay, then because of that, probability that y equals 0 plus probability that y equals 1 should be what?
1.
Yes. So from here, what's the probability of y equals 0?
0.035?
No. That's right. But the thing is, I'm going somewhere. Then what is this? Can you tell me? For Bernoulli, random variable, we showed before that expectation of y equals what?
1 minus p.
Which is p, right? The p is the probability of success, right? So the success here is being employed. Do you agree with me? So then you can substitute this for this, and it will be probability 1 minus expectation of y. And this is what they wanted us to show. So we showed that probability that y equals 0 is 1 minus expectation of y. That's what they wanted us to show. Now see, calculate. Now we are asked to calculate something else. Let me copy this once again so that in here, then we are asked to calculate expectation of y conditional that x equals 1. Okay, so that's what? That's, how can you write it? It's yi times probability that, that y equals yi conditional that x equals 1. So then, but I changes from 1 to what? Guys, I do need your involvement. 2 because what? Because of?
There are only two possibilities.
For?
Unemployed or employed.
That's right, but for that's exactly right.
Why are we not writing that, Professor? 0 and 1.
No, this is like a general formula.
Oh, I see. It's not for the specific case. I see. Okay, sorry.
I am now giving you, yeah.
What does the vertical line mean between x equals 1 and y equals small?
This means,
yeah, that line. What does that mean?
Conditional that x equals 1. This is a conditional probability.
Got you.
So what's the first possible outcome of, and okay, then this will be yi. Can you tell me, so do you see this conditional probability in this table?
Yes.
Which is that? No, we don't. Why? Because in the middle we have joint probabilities and on the sides we have marginal. But the thing is, you can calculate that, right? How? this is probability that y equals yi, guys, and x equals 1 divided by probability that x equals 1. That was from before. I changed from 1 to 2 in this case. Okay, then now what's the first possible outcome of y? 0, right? 0 times probability that y equals 0 and x equals 1 over probability x equals 1 plus the next possible outcome is 1 times probability that y equals 1 and x equals 1 over probability that x equals 1. This will be 0. Why? Because of this 0. Because first possible outcome of y is 0. But it can be that it's not 0 because I can give you like 5 or 6 or whatever number of the first possible outcome of y. In that case, this term will not disappear. Now it disappears. So then this is 1 times whatever is that, and then what is this? What is probability y1 and x1? And probability x equals 1, that's
0.398.
Yeah, go ahead and ask, guys. Do you have any question?
No.
This is approximately. And of course, you can calculate this similarly expectation of y, conditional that x equals 0. And you will obtain that exactly what I did before, like that. You will obtain this. And the final part D asks us for calculate the unemployment rate of the college graduates and non-college graduates.
Professor.
Yeah.
So I have 2 questions. You said probability y equals 1 comma x equals 1. So does the comma represent a multiplication?
Comma is n in this case.
No, but you said 1 times p y equals 1 comma x equals 1 on the top.
Yeah.
So does that comma mean you're multiplying y equals 1 and x equals 1?
No. It's like 1 times this term, but this is in the numerator probability that y equals 1 and x equals 1. And you see this in this table, probability y equals 1, you are in this column, x equals 1, you are in this column. So then the probability that y equals 1, x equals 1 is on the intersection of the 2, right? So which is 0.389.
Okay, I got it. Thank you. So it's like coordinates, really.
Yeah. So it's like this is the probability that y is 1 and x is 1.
Okay. Yeah, I thought it was like you're multiplying it or something. It didn't really make sense. And one more question.
Yeah.
So you above that, the circle you just drew, you have p equals y to the I, right? Do you see that?
Which one? No.
So you have p comma, parentheses y equals y I comma x.
This one.
Right under that.
Okay, this one.
Yeah. So can you just show me how y equaling yi is the same as y equaling y0?
Okay, so the yi is like the yi is y1 or y2, right? Because I is either 1 or 2, and y1 is equal, in this case, the first possible outcome is y1, that's the first possible outcome is 0. And the second possible outcome of y, which is denoted by y2, is 1.
Okay.
You see what I mean?
Yes. Thank you.
So next question. Nice. Now, I mean, you have to think a little more, think very critically. This is the expectation of y conditional on x equals 0. Okay, but this is also the probability that y equals 1 conditional that x equals 0. So then, if the question is, what's the probability that y equals 0, conditional that x equals 0, that's 1 minus probability that y equals 1, conditional on x equals 0. And you have calculated this before. This will be 1 minus probability that y equals 1, conditional on x equals 0. That's, where is that? Do I have it? Yeah, that's this number because of this, whatever I said now. So this will be 1 minus 0.917, and that's 0.08 and 3. Similarly, you can calculate probability that y equals 1, but x equals 0. But we know that this is because phi is a Bernoulli random variable and x is a Bernoulli random variable. That's exactly equal to the expectation of y equals 1, conditional x equals 0. So then, do I know this? You know, you calculated this above. Sorry, here I should have 955. I should have 0.958, and that's 0.042. And here you have, this was like I mixed it up because this is probability that y equals 1 and x equals 0, then that's 0.970. This is 0.917, and then clearly probability that y equals 0, conditional x equals 0. This is 1 minus probability that y equals 1, conditional x equals 0, and this will be 1 minus 0.917, and that's 0.042. Sorry, 0.083. Even though I gave you like all the explanations in this part as well, think about this. This is really interesting. And if you have any questions, let me know. Right, but I mean, this is because both phi and x are Bernoulli random variables, and we showed that expectation of y equals probability that y equals 1. Right, and then whatever is your condition does not really matter. Then you can say, what is the expectation of y? That's conditional on, let's say, x equals 0. That is exactly probability that y equals 1, conditional x equals 0. And also because of this, you can also say expectation of y when x equals 1. This is probability that y equals 1, conditional x equals 1. Right? So think, because my students always are good thinkers. So think about this. If you have any questions, feel free to ask. Okay, so then what is left? E. A randomly selected member of the population reports being unemployed. What is the probability that this worker is a college graduate? So the condition here, can you guys tell me what is the condition here? Guys. The condition is that this person is unemployed, right? And then you are interested, is this person a college graduate? So it's like this. This person is unemployed, so this is like probabilities that person is unemployed, which means in this case what? From this table. How can you write that the person is unemployed?
X equals 1?
No, y equals 0. Y equals 0. That will be the condition, right? And you are interested, is this person a college graduate? So X equals what?
1.
Yes.
Isn't it the other way around?
Really? Why?
So this means probability that a college graduate.
Given.
Can you explain what this means?
Yeah, this means that's the probability that the person is a college graduate, given that this person is unemployed.
Okay.
So
isn't the question asking you the other way around?
Maybe, I don't know. Let's see. The question is, you are selecting someone who says that I am unemployed. And then you are interested, is this person a college graduate? So before you ask a question, the person is already unemployed.
Okay, so, okay.
Do you see what I mean? So this will be probabilities that X equals 1, comma, which means and Y equals 0 divided by probabilities that Y equals 0. And you can calculate this from the table because probability X1 and Y0 is what? 0.009. And the probabilities that Y equals 0, that's 0.035.
So Professor,
yeah.
How is this different from what we just did earlier? Like, this is a lot more simpler than the previous example you had. Like,
yeah, right. No. This is the probability. It's not the expectation. The previous examples were about the expectations.
Okay. Oh, okay, yeah.
What's the expectation that you are, let's say you are unemployed, given that you are a college graduate? That's the conditional expectation, but that's not the probabilities that you are unemployed conditional on that you are a college graduate. So please try to see a difference between conditional expectation and conditional probability. Probability and conditional expectation.
Professor, can you, after you're done writing, can you just scroll up to the expectation example we had?
Yeah.
Yeah, just a little more, like right at the beginning. Yeah, right here. Thank you.
And the last question is, are educational achievement and employment status independent? So the last part. So we have random variable x and random variable y. Random variable x is said to be independent of random variable y if the probability of x and y equals probability of x times probability of y, or you can also check if probability that x given y equals probability of x, or probability of y given x equals probability of y. So, okay, what did I do? Y. So, and then if this is true, then x and random variable x and random variable y are independent. Okay, so what is the probability? Let's check it. You can check just one probability that, let's say, x equals 0 and y equals 1. If this is equal to probability that x is 0 times probability that y is 1, you will have to check other possibilities too. But if this is not true, then they are not independent. What's probability that x equals 0, y equals 1? Can you tell me from this table? x0, y1, 0.576.
Can you, okay, so x equals 0 and y equals 1. Are you on that quick?
I just forgot. So what was the probability x0, y equals 1?
0.576.
Please remember that. Versus probability x equals 0 is what? 0.602. Times, what's the probability y equals 1?
0.965.
Yeah. And they are not equal. So they are not independent. So x and y are thus not independent.
Is this what we're doing for next class? Or
No. This is like an end of today's class.
okay, gotcha.
So I solved certain problems today, and I hope this was good exercise for you guys. The homeworks you will find that are very similar to this, and there of course are additional questions that you will be asked to complete, but it's okay. That's how we learn. So this is the end of today's class.
Professor, are you having office hours after this?
No. I will have office hour on Monday, next Monday.
Professor?
Yes?
How does attendance work here? Do you take attendance or is it automatic?
Automatic.
Okay. Thank you.
And quick question, when will the lecture be up for this class?
For this class, like in a few hours, because it needs some time to convert into the video, and then I will upload the link on the Kenny Blackboard.
Okay.
Like by the evening, everything should be there on the Kenny Blackboard.
Thank you.
Professor, real quick, so for the examples, you really just plugged it into the formulas you gave on Sunday, correct?
What?
So as you were doing the examples just now, you were basically just plugging in the numbers into the formulas you gave last class, correct?
Yeah. Last class, I just gave you guys a lot of different formulas, and I wanted you to see how they work. And that's what I did.
Okay.
What I did today. Okay.
Thank you.
Okay, guys, that's it for today. And I'm really happy that I have a lot of students in class, and please keep going that way. And I will see you on Monday. If you have any questions, you can always reach out. Have a nice day, guys.
Thank you for the class.
Thank you,
Thank you.
Professor.
Thank you,
Thank
Professor.
you.
Thank you, guys. Have a nice day. Bye.
Thank you, Professor. See you Monday.
See you Monday. Thank you.